Hello, my name is Rich Howard, owner of Architectural Builder Supply. In this video is to bring you a closer look at the Von Duprin number 5100 series electric strike. This electric strike from Von Duprin has been on the market for several years, and I continue to go back to it over and over and over again on jobs that I specify because it is incredibly capable right out of the box. It can do different things in terms of different faceplates, field selectable for voltage and function or operation. And while I'm specifying it, I already know all of those parameters going into it. I do like to rely on the fact that should something change, like the function of the strike, or maybe the voltage as prior or previously discussed with the client changes, the strike right out of the box can handle it. So this video is going to go over a visual tour of the item, a dimensional review of the item, the contents, touching on the installation instructions, how to prep the frame for it, and let's get started. Now at this moment, let's move into taking a visual tour of the item itself. Here's the box, and the only thing that I've taken out is the installation instructions, which are linked to down below this video, and we're going to go over those in a moment. So let's take a look at what you get with this 5100. In no particular order, you're going to get fasteners and a couple of wire nuts. We'll point out where all that goes. Another nice thing that I like a lot about Von Duprin, we'll go over my Von Duprin fanboy opinion at the end of this video. You're going to get mounting tabs and shims that will allow you to take this right out of the box and install it to your aluminum frame, your wood frame. Well, your aluminum or your steel frame. And obviously a wood frame, you won't need those tabs. But the point is, you don't need those. They're included. Okay, not that it applies to my applications because I'm specifying it from the beginning, but you're going to get three faceplates. The two outer ones, those are both going to be your 4 7/8 height type strikes with either square corner or radiused corner. Okay, obviously aluminum storefront, you're going to want to use that radiused corner. Square corner like this is going to be your hollow metal frame, and if you're retrofitting something and you need a faceplate that's going to be this height, and we're going to go over that dimensional property in a moment, well, I can tell you right now, it's 7 5/16, you have that ability. So if you're replacing a strike that has that 7, forgive me, I said 7 5, I mean 7 15/16 dimensional properties, you're getting this right out of the box. I tell you, the only thing that they don't do out of the box is give you the ability to do dark bronze or aluminum. You do have to specify that. Anyway, now moving on to the business end of the strike, you've got the keeper, you've got the solenoid internally, obviously. A nice feature is that they put the wiring diagram right on the back of the unit. Okay, 12 volt or 24 volt. Your faceplates are going to mount right to the body itself via these two holes. You're going to be able to make some adjustments to it, and that exhausts all the pieces that are actually in the box itself. Now let's move on to dimensional properties of these items. Part of why I'm so partial to Von Duprin is because, you know, their technical support department, it's superb, it's exceptional. Every time that I call them, I get somebody who is utterly expert at the question that I'm asking, and I get in touch with them. I don't have to call very often, but when I do, what I mean to say is I don't have to call very often because a lot of these things I already know myself after a quarter century of experience. So if I'm calling them, it's generally something that's not, can you please tell me the difference between AC and DC voltage? It's some, a bit more exotic question. And I am thrilled how expert they are at being able to answer these questions. That's your hollow metal. 4 7/8 tall. This is intended for a hollow metal frame, as is the aluminum. Again, the only difference is radius corners. Why radius corners? Well, if you're new to that, if you're prepping an aluminum storefront frame, you're going to probably be using a router and you're going to want this small little radius that's going to be on here shown laid on top of each other. Okay. That's the only difference. Then you've got the 7 and 15/16, and this is going to be appropriate when you're retrofitting over other manufacturers' material. 7 and 15 overall height, overall width of that plate, about 1 3/8 inches, maybe 1 7/16 inches. Okay. Now to any of these plates, you're obviously going to bolt the unit right down to the plate. Those two tapped holes, the two countersunk preparations in the faceplate. I'm really looking this up. Going to give you that kind of look. Okay. That is going to explain the two short screws that you see. Sorry. There's two of those in the package. That's those two little short screws. Since we're talking screws, you're then going to have two wood screws, two of those, and then two machine screws if you're doing either the aluminum or the hollow metal installation. Okay, right there. And of course the two wire nuts, and it's obvious where you're going to use those. The mounting tabs, you know, they're packaging in here some shims. And those shims are to account for. And the reason they're going to have these shims is that the thickness of the metal, whether it be steel or aluminum, and the offset in the mounting plate, and in this case there is no offset, needs to be accounted for when you're installing the tab, because you have to install it so that the faceplate is flush. So if the wall thickness of what you're installing the strike onto is equal to this faceplate, probably not going to need the shims, but it's probably not. Aluminum's probably going to be thicker. This faceplate thickness is 0.108, 0.108, and certainly 16 gauge steel is thinner than 0.108. So you're going to need those shims, is why they supply those. Obviously, installing these mounting plates, once you, and we'll get to the preparation, once you install the mounting plates into the frame, you're going to need to drill and countersink the aluminum frame, certainly. The hollow metal frame, a little bit more difficult to countersink for that because the material thickness is so thin. But these screws are actually flat undercut head screws. They're undercut head, and what that means is that allows them to become more flush. Look at the profile underneath the head. That allows you to get a better countersunk flush condition onto a hollow metal frame. Now, if you're a shop or if you're an installer, it's very likely with a steel frame that you're going to weld those tabs. When in that case, all that you're really going to do is drill a hole through your frame. You should drill two of them. And make sure you've got a couple of holes, you know, in your tab, and then just plug weld that onto the frame is what you would do. What we will do is take like a generic 4 7/8 strike and prep the frame, cut the required size in the frame, attach the tabs to the strike, and use the strike as a handle, and then weld those tabs down into the back side of the frame. If you don't have access to the back side of the frame, you can plug weld in the same sort of scenario, using a strike as a handle and holding it to the frame. The downside of welding in the field is the hazards of doing so. 1800 degrees, smoke detectors, a combustible wall construction. So all of that comes together to usually excluding welding as an option, but if it's in a shop controlled setting, you might want to consider that. Obviously, something welded, in my opinion, is less maintenance overall than something that's been screwed together, which is my argument with hollow metal doors over aluminum doors. I like my stuff to be welded together rather than screwed together like it is in aluminum construction. Regardless, moving on. Dimensional tour, the strikes we've talked about. Let's go over the strike body. The width of those 4 7/8 plates, that's going to be 1.25 inches, and that's standard. Overall width to the outside of the box, about 1 11 sixteenths. Overall height of the body, about 3 3/8. Okay. Overall depth of the body, that's going to be important. You're going to be right at about 1 11 sixteenths again. And keep in mind your frame face profile width and your wall construction needs to accommodate the strike that will be that deep. It's very possible if you're installing this into a knockdown hollow metal frame, you'll have to chisel into the stud construction that's behind the wall. So that might be required. I wouldn't worry too much about that, but you'll have to make clearance to run that. And obviously the ability to run wire power to the opening as well is something that you'll have to consider. And there's lots of ways to do that, some less elegant than others, but nonetheless, if you have questions on how to wire it, bring power to the opening, feel free to reach out to us. Now the next part of the video, let's start to tackle the installation instructions, and again, they're included. And let's go right to page 4. Page 4 is going to allow you to review the dimensional properties of the strike in totality. Okay, you'll be able to see what it's going to look like in all regards. So you want to have an understanding of what your dimensional requirements are going to be right from the get-go. And I like to, not that I discover errors, but 1 out of 1,000 times you will discover something that seems, oh, I'm going to adjust that for whatever your circumstances are. And the important part really of reviewing all of this is understanding that you're dealing with a cutout on the face of the frame. Sometimes if you're doing a hollow metal frame, your hollow metal frame is probably already prepped for the 4 7/8 tall strike by 1.25 inches, so no work to do there. But you will have to scooch back and around the face as shown in page 4. And that dimension is, if you recall earlier, we called it out at 1 11 sixteenths. So that would be the dimension that you would prep. Plus, you know, when you make that line, go to the outside of that line. Give it an extra 32nd of an inch for, as a general rule. Not always, but as a general rule, give it that small amount of additional requirement. Now, aluminum storefront, that's going to require that 5/32nd radius. So if you're dealing with you know, a router bit, you're going to want to make sure that you've got the proper size router bit for that. Let's see here now. 2 5 sixteenths is what you're dealing with in terms of a router bit diameter to prep for that. Does that make sense? 1 divided by 32 times 5 times 2. 0.3125, yeah. So you'll need a 5/16 of an inch diameter router bit to leave you with that clean 5/32 of an inch radius that you would need in your aluminum storefront. The long face plate, that's mentioned there as well in terms of the height. The width on the face of the frame for your prep won't change. So all of page 4, just dimensional properties, and now we've completed 25% of the installation instructions. Moving on. Let's circle around and get to page 1 of the installation instructions. And the top of page 1, the first top half of it goes over the 3 face plates. We've discussed those. Step 1, for lock preparation, see the lock instructions. Install the correct strike. Prepare the frame for the strike, page 4, which we've already reviewed. Now, Make sure strike operates in the correct mode, and this is a reason why I like the Adams Rite, why I like the Von Duprin strike so much. It can factory out of the box from the factory be configured as fail-safe and fail-secure. Simply put, the term fail-safe or fail-secure, safe or secure, refers to the door when the door is in the closed position and the power is out. When the door is closed and the power is out. Do you want it secure, which means it's locked, so when it fails locked, or do you want it safe, meaning that you can safely enter or exit, possibly? A lot of installations require fail secure. When the power is out, the door is locked. You might think of an application like an institution, a nursing home, hospitals, places where in that sort of event you cannot have certain doors automatically unlocked. If it is a 3-flat building, a 3-apartment building, typical Chicago 3-flat, front door of the building, intercom connects to it. In the event of a power outage, you probably want the power off. Why? So the fire department can get in without breaking the door. Access, getting in. That would be an example of why you may want to fail safe. Power off, doors in the unlocked condition. You can pull, literally the keeper can be pulled open. Now, when I tug on that, it's locked. So therefore, this is already set in the fail secure condition, which indeed is the most common condition, but not necessarily exactly what you need for your application, so do keep that in mind. So, lower right-hand corner, you're going to see how you will adjust the actuator based on the mode, fail-safe or fail-secure. Very simple and straightforward. You are going to simply remove this plate to gain access to that actuator, and I'm going to get my screwdriver, pull that off, and we're going to take a look and confirm that it is in the fail-safe mode at this time. Okay, so what I've done is tug back both of those decals, because this is going to a client. We don't want to give the impression that we've tampered with this lock very much, because we're not tampering with it, we're just reviewing it. Those screws are in there pretty good. Whenever you remove a case, a cover from a lock, a mortise lock, whatever it is, cover that. Leave pressure on that. You never know when a spring on the inside is going to jump. I get that call once a month. I opened up the lock and I lost the spring. Okay, what lock do you have? I don't know. How old do you think it is? Well, the building was built in 1950. Doesn't feel like there's anything in there. However, as soon as I pulled it off, the parts are no longer connected very well at the bottom. So, what are we doing? What we're doing at this point is we are verifying the fact that our electric strike is indeed in the fail secure mode. I tugged on that keeper, and that's called the keeper, and it's locked. And you'll see that the teat portion of the actuator is indeed pointed in the down position, as seen right there. Okay, and that's why that operates that way. If you were going to remove that, or redo it, change it, I should say, into fail safe, you're just going to flip that over without any trouble at all. I don't think you're going to lose these parts. There's not too much to lose there. This can come off easily. Grab that little handle that's at the tip of my finger and you can retract the locking bar up into the solenoid. There's our actuator. That came out. So we're just going to put that back. You will notice that there is also the different hole that you will install. So in a fail-safe, with that teat up, you're going to utilize that first hole here. But in a fail secure mode, with the teat down, you'll utilize that other hole. That's where those dashed lines go through. That's what that's referring to. Okay. I'm going to put this back in its condition. I'll leave the video run and just see how long this takes. There you go. Perfectly reseated the precise way that it was originally. So whatever, 15 seconds. At this point, we're going to move on in the installation instructions, but I won't put the cover back on because I don't know if there's something else we need to look at. That's how you control fail-safe, fail-secure, and that's what the definition of them are. Now, wiring. Wiring is going to be all of page 2. Out of the box, it's going to allow you to do AC or DC AC voltage is not done out of the box, only DC, 12 or 24 volt DC. AC strikes, if you hear a buzz, then you have an AC strike. If you only hear a click, that's DC. DC wiring is most common for hardware like this. If you need to do a AC operation, that's referred to in the installation instructions here. It says for AC operation. That is one of the two things that you have to select when you order this strike. What color, and are you using AC? Specify the voltage. If you're using AC, there's an adder because we then send the rectifier that you would use for this, meaning that it will take your AC voltage and permit the DC wired strike to accept AC voltage. In that case, you'll have a buzz operation. A lot of people like that because they literally feel, and I don't disagree, that a buzzing sound is what you hear when it's time to pull the door open. And when the buzzing stops, the door is locked. A front door of apartment we talked about earlier, AC I think is really the way to go with that because you do want to hear that buzz. However, that would be very inappropriate in a lot of instances where you would have a buzzing sound. Think of a commercial setting where you've got key card access to a employee door where there's 1,000 employees, and then there's the receiving personnel that are there. They don't need to hear a buzzing sound 5,000 times a day. The wiring is listed for AC or DC configurations. Can't tell you which is more common, except that I'm quite convinced 24 is more common. So your red and black go to your input, to your transformer. You tie off your red, white, black, white wires. In that case, it seems like to me you're going to be short a wire nut. And indeed, there are only 2 supplied, so keep that in mind. You're going to need a wire nut, most possibly. Step 4, once you've got it wired, obviously test it. Carefully tuck your wires back. Moving to the bottom of page 2, test the strike, as I just said. Apply power, test it, make sure it locks and unlocks properly, make sure that the power off condition is correct. Obviously, this strike is meant to be operated not continuously. You wouldn't run power to this continuously. Like a fail-safe application would be always energized, and when the power is cut, it would be locked. This would be an intermittent type of strike application. The bottom of page 2 talks about if you've made the cut prep too wide. In that case, it basically says, cut to length a piece of neoprene filler. That's not included anywhere in here, so don't cut it too large, otherwise you're going to have to fill that. Some manufacturers make scar plates to contend with that. You'll have to fill that somehow should you get into that sort of trouble. Moving to page 3, if you don't have the mounting tabs already or your frame is not prepped, you're going to do the mounting tab installation, and that's all talked about there. And you'll recall we talked about the application of the shims. Frame too thin or frame too thick instances are discussed in those installation instructions, top of page 3. Now, another reason that I like this strike a lot is because the bottom of page 3 talks about how you can adjust the strike lip to account for, and now I'm going to pause this. No reason to pause. The adjusting of the strike lip allows you to contend with the position of the latch bolt and the edge of the door not exactly where it needs to be. I'm putting this plate back on. Visually inspect to make sure that your gap is basically 0 all the way around. You don't want to have a part not seated correctly, tighten the screws down, only to then power it to find out that it doesn't work correctly. When you put the screws back in, lay that flat, gives you less of an opportunity, in my experience, to lose that screw. Don't tighten it down all the way initially. Get the other screw in mostly, because what you really want to do is apply constant, even pressure all the way down. Tightening it down in one place might cock the plate up a little bit, allowing a spring to move. Not so much in the 5100 strike, but when you're dealing with mortise locks that have lots of internal parts, meaning it's an entry function that incorporates a deadbolt. That's just what I have found gives me the best results. Now, you can tailor the vertical center line of the keeper slightly to account for a latch bolt that's a little funny. Meaning, it might not be in the exact center of the door, meaning the strike prep may not be in the rabbet in the right location. The door might be hinge bound, and it might be literally tipping out a little bit where you need to adjust that point because it's not here, it's actually here. So you can scooch that by using these two bolts that are here. Allen wrench, there is not an Allen wrench included. And you'll be able to adjust that. Install, make sure the clearance between the latch bolt and strike lip is a 32nd of an inch, figure 9. Figure 9, the bottom of page 3, left side, shows you what they're talking about. Basically what that means is when the latch bolt is in the strike keeper, the distance from the inside face here to the face of the latch bolt needs to be a 32nd of an inch, a small amount, tiny amount. That will give you the ability for the fist is the latch bolt, this is the keeper. You want this distance right here to be just ever so slight, meaning that there's not undue pressure pushing against the keeper, because what happens sometimes is the keeper is bound and cannot reliably open. You want to have that small amount of breathing space so that it can be powered, the strike can be unlocked, and then the door can be pulled and the latch will push the keeper open. So you don't want to have that sort of consideration, condition whatsoever, and make adjustments if that is indeed the case where you've got a bound condition where the latch is making undue pressure on the strike. And I'll get calls relatively often, and the client will say that they're having that sort of trouble with the installation, and a reason that I like Von Duprin is because you get the ability to adjust the strike in that sort of fashion. Now, another important note there is that 5/8 of an inch maximum latch bolt projection. Generally, you're going to encounter latch bolt projections, how far the latch bolt sticks out of the faceplate, of either 1/2 inch or 3/4. You're going to use a lock that has a 1/2 of an inch projection with this electric strike, because a 3/4 inch latch is not going to be able to fully extend, permitting the condition that the lock might still be in the locked condition. You've got too much latch bolt going into a keeper. That's just simply not going to work. Now, you can make that work. It will work if the gap between the edge of the door and the frame is excessive, like a 1/4 inch, because it's just a really huge gap. But if you have a 3/4 inch latch projection on your lock, like you will with a typical grade 1 lock, cylindrical or mortise, certainly something fire rated, this is not the right strike. You're going to need a different strike from Von Duprin. Getting back to page 4, that concludes everything about this strike that I can think of to mention. Mentioned early on why I'm a fan. It's because of that technical support that we get all the time from them. The Von Duprin name is synonymous with very high quality material, whether it's electric strikes. Certainly there's 6000 series electric strikes that have been in the market for decades. The availability of not only the strikes on the shelf is generally exceptional, but the ability to buy just the parts. Let's say you've got an exit device, or an electric strike in this case, and you need only a piece for it. Not only does Von Duprin publish those parts lists, gives you those parts numbers, show you how it's installed in terms of the parts drawing, but it's generally in stock as well, so that you can buy only the part you need to continue to get useful service out of this otherwise significant investment in hardware, especially exit devices, most certainly. So I'm partial to them for that. And then again, back to the excellent technical support. If you have any questions on the Von Duprin 5100 series strike or any other Von Duprin product, please feel free to reach out to us. Thank you.